Hello, and welcome to Astro Skills. I'm Tom Arnold, and today we'll be talking about the procedure of pre-processing your images. Correctly processing raw astronomical images is critical in obtaining the best possible result. Pixinsight, seen here, provides an excellent tool to accomplish this: Weighted Batch PreProcessing. This single tool will calibrate your images, detect linear defects, debayer those calibrated frames if this is a one-shot color camera, then measure the images for creation of a reference frame that will place solve your target to aid in registering all the images together. WBPP will then create a reference frame to normalize the entire set to this point. This step is important to compensate for changes in contrast that occur as the sky changes throughout the night. Once that is accomplished, this image will then be integrated into a single final frame. This will be a single one-shot color frame, or OSC. That is also different from an individual narrowband frame such as hydrogen alpha, oxygen 3, and ionized sulfur. After all this processing is automatically complete, your final, highly calibrated single one-shot color frame or narrowband frames will be ready for processing. To begin this process, your task will be greatly simplified if you have set up a special directory on your computer to contain all the necessary files to run this process. Call it simply Calibration. That master folder should contain your set of bias frames in a subfolder, the dark frames in a subfolder, the flat frames in a subfolder, and all your light frames in a subfolder. If you are uncertain what these types of images are, please seek other astroimaging sources for explanation. This calibration folder will be identified later as the location for all your pre-processed images, and more importantly, your final pre-processed images. For this demonstration, I've created folders under the Flats folder to contain the one-shot color frame along with the narrowband frames, hydrogen, oxygen, and sulfur, as an example only to identify the location of these two types of calibration sets. Once you have purchased and installed the product, navigate along the top to Script and click. Move down one space to find Batch Processing. Then proceed to the bottom of the list to Weighted Batch Processing and click. This will take a moment to load, so be patient. You will finally be presented with this page. Along the top, reading left to right, you will see bias, darks, flats, lights, calibrations, post-calibration, and pipeline. At the bottom of the page, you will see directory, files, bias, darks, flats, lights, and add custom. The green plus sign indicates that this is where we enter each of these image sets. The most important four selections are adding bias, darks, flats, and light frames. While we are along the bottom of the WBPP screen, look to the right. You will find a small section called Output Directory. Click on the file icon to the right of the input window and browse to the calibration folder you've created. As we stated before, all the work from this script will be placed in that folder. Now we can begin adding files. They can be entered in any order you wish, but for the sake of simplicity, let's begin with the bias frames. Click on the Bias tab along the top of the page. The bias input appears on the screen. At the bottom of the page, click on the Add Bias button and navigate then to the bias files you have in your calibration folder. Select all the files and click Open. All the files will appear in the large window. At the top of the list of WBPP, it identifies the binning of these frames along with their pixel size, in this case 6280 by 4210. Please note, in the case of all these input tabs, you can choose to remove any of the files from the list by simply selecting those files and then click on the Remove Selection button to the right of the screen list. To the right of the screen are numerous inputs. At this stage, just accept all the default values. We'll talk about those later. Next come the darks. Click on the darks at the top of the page. Then click on the Add Darks at the bottom of the page, navigating to the location of your dark frames in calibration. Select all the dark frames and accept the defaults for the inputs. Next are the flats. Click on the flats at the top of the page, then click Add Flats at the bottom of the page. Browse to the flats and add them as before. Please note, if you're imaging in one-shot color, narrowband, or regular RGB, you can add all the different colors at one time. Pixinsight will understand the difference and work accordingly. It'll save you a lot of time in the long run. Finally, we can add the lights. All your light frames, regardless of color or frequency, can be added in this window. As the flats are entered, Pixinsight will understand the difference for the lights as well. Here, we are presented with a series of additional windows. In some of these, we will modify the default values, while others we will leave unchanged. To start, check the box in the left corner of each of the 6 selection windows, to the right of the file input window. We should allow Pixinsight to run these procedures, creating the final processed image. Now, beginning with the first box, Linear Defect Correction, change the default rejection limit to 2, and click the drop-down Correction Type to columns and rows. Under Subframe Weighting, select PSF Scale SNR. Next is Image Registration. Click on Registration Parameters and make the following modifications. Change clamping threshold to 0.2. Maximum stars, check distortion correction. Detection scale is set to 5. Minimum structure size is 1. Hot pixel removal is 2. Noise reduction is 5. Sensitivity is 0.5. Peak response is 0.5. Bright threshold is 3.0. And maximum distortion is 0.6. To move to the next selection, click the red X on the top of the image or registration window. For astrometric solutions, uncheck the interactive in case of failure, unless you specifically require data. This information will normally be included within the FITS header of each image, recorded by the imaging software and read by Pixinsight. But regardless, the astrometric solution checkbox should be checked. Local normalization. I uncheck interactive mode. Otherwise, Pixinsight will go through each light frame and ask for input from you. If you have a lot of frames, like this example of 98, that's extremely time-consuming. Try these inputs under Normalization Parameters. Uncheck Generate Images. Set reference frame generation to integration of best frames. This means select only the best frames for stacking. Maximum integrated frames is 20. Elevation criteria PSF single weight. Grid size is 3.0. Scale evaluation is multi-scale analysis. Growth factor is 1. Maximum stars is the default. Minimum detection signal to noise is 40. Check allow clustered sources. Low clipping level is the default and high clipping level is the default. Finally, we reach image integration. Click on integration parameters to be sure the rejection algorithm is Winsorized clipping. That is, if you have 20 images or more. Otherwise, just select auto. But the cutoff is about 20 for Winsorized clipping. This demonstration is using one-shot color frames. Pixinsight must be told how to process them. Click on Calibration along the top of the page. You will be presented with this page showing the bias frames at the top, followed by darks, then flats, and finally a row called lights. Along the bottom of the light window is a large horizontal slider. Move it to the right as far as it will go to find the last heading, CFA Images. The black No is only pertinent for narrowband or RGB frames. For these one-shot color frames, this has to be changed. Click on the black No. The bar changes color and a new selection appears on the right. That is CFA Settings. Check CFA Images. On Mosaic Pattern, click the drop-down and select RGGB if this is the pattern for your camera. If you're unsure what the pattern scheme actually is, consult its product manual. Now, we have to define the debayer method. Click the drop-down and select VNG. Since our flats are also color frames, click Apply to All Light Frames. If you're curious about the workflow of the calibration process, click Show Calibration Diagram. Look up this setting column to find calibration settings. Be sure both dark and flat are checked, and each set to auto. Any other inputs on this page should be left in default mode. When all this is complete, click Run to begin the process. After clicking Run, the first window we see is informational, showing the amount of disk space required for your calibrated images. This process of 98 frames will require 25.35 gigabytes to process. Check your available disk space to be sure you can accommodate that much storage. Otherwise, the calibration will fail at some point in the process. Click Continue to proceed. The next window will show the process to be completed. As WBPP proceeds through the process, the elapsed time and status are recorded. With this window, the degree of complexity becomes apparent. Your computer will have a lot to do and will take a considerable amount of time to complete each process. For this reason, this demonstration will only process a set of 10 images, which took an hour and 13 minutes, whereas the original 98 frames took 6 hours to process on a 3.5 gigahertz computer. As we near completion, the Notes column provides comments on the process. A notable entry is linear defect correction. The 0 in comments means it found no linear defects to correct. In addition, we can also see the indication of the number of frames processed and the number of failures that occur, if any. After our long wait, WBPP completes the task showing this screen with all the processes done, and an overview of the results are provided. Click Done when you're ready. The final frame provides more information on the calibration process. Scroll through the list as needed. You can choose Save this report or click Done to end. Here we can navigate our calibration directory and find the results. With the calibration directory open, we find the WBPP has created other directories: debared, logs, master, and registered. To find the final image, open the master directory. Here you will find the following. The first file is local normalized reference. Next is the master bias, then the master dark, the master flat, the master light RGB. Please note that these masters, the dark and the bias and the flats, can be used later on in Pixinsight. At that point, all you have to select is the master file, and you won't have to load all the files individually. Your final master light RGB autocrop. This is the file we're looking for. This is your final image. If you have Pixinsight still open, drag it onto the workspace. Otherwise, open the image under File Open in Pixinsight. Don't be shocked when these two images are open. They're black. What happened to the image? Fear not. It's there, it just needs to be stretched. Go up to Processes, All Processes, over, then down to Screen Transfer Function. You have two black images on the screen. Click on the one that does not have Auto Crop Mask in the title. Then, on the nuclear button on the Screen Transfer function, hit that button. Bingo! Here is your final image. You can delete the mask image if you like. Once you have finished admiring your work, save it. Now, it will be time to begin your next processing of the actual image. If you have found this tutorial helpful, please click the like button and subscribe to the channel. We will soon provide other videos detailing many more procedures in Pixinsight that detail processing workflows for calibrated frames such as RGB, narrowband, and one-shot color. Finally, thanks for watching.